Ladies and gentlemen, listen up. For those Algebra 2 classes in the morning, I said you could use synthetic division on any of these problems, but the truth is synthetic division gets really confusing when you have an a value that's other than 1, okay? So right here we have the a value of 2. You do not want to use synthetic division right here. I'm sorry, if you have an a value other than 1, you have to use long division. Once again, if the a value of your divisor is not 1, then you must use long division, okay? So right here, even if you wanted to use synthetic division, it gets a lot more confusing, so it's better to just go with long division, okay? If it were just x minus 3, then yeah, go for it, use synthetic division. But it's 2x minus 3, so don't use synthetic division, use long division. And I'll tell you why. Let me show you. Using long division, your numerator goes on the inside of the division box, and your divisor, 2x minus 3, goes on the outside. So it's better to just think, okay, 2x times what will give us this exact 4x squared? 2x times 2x will give us the exact value 4x squared. And if you distribute, we already did 2x times 2x, that's 4x squared. How about 2x times negative 3? That is negative 6x, okay? And we are going to subtract, which means you put in parentheses with the minus. So you're going to distribute it, and you get a minus there, and you get a plus over here. So what we really have is these guys canceling out. We have a positive 4x, and we bring down the plus 6. And once again, you go 2x times what will give us a 4x. That's going to be plus 2, okay? Because 2 times 2x is 4x, and then 2 times negative 3 is negative 6. And of course, we are subtracting. So let's put this in parentheses, and the minus sign, that's going to change it to a negative 4. That's going to cancel. It changes that to a positive 6. You will get a remainder of 12. So at the end of it all, you're going to put plus fraction 12 on top of the original divisor, 2x minus 3. So this is the correct answer, guys. 2x plus 2 plus 12 over x minus 3. And if we were to try to use a long division, it would not give us that answer. It gets more complicated. Just think of it this way. Long division, you end up with, by starting it by setting this equal to 0. And if you did set that equal to 0, you would get x equals 3 halves. Now, if you were to think about long division, that means that you'd have to put 3 halves inside the box, right? Now that's already ugly, and then you'd have to put your coefficients 4, negative 2, and positive 6, and then the 4 would come down, and you'd have to multiply through it, and guess what? It's not going to work out, because if the 4 comes down, 3 halves times 4 is 12 halves, which is 6, and then that gives you a 4, and then 3 halves times 4 is again 6, and that gives you a remainder of 12. Now, normally I would say your answer is 4x plus 4 plus, and what's this going to be? It's going to be 12 over the original divisor, which was 2x minus 3. But if you compare this synthetic division answer with the original long division answer, they're different. That's because when you have a fraction out here, the divided by 2 has to be done to these outside guys, or these first, the polynomial term, not the remainder. So you'd have to divide everything by 2 to actually get the 2x here and to get the 2 over here. So how about this? Let's not do synthetic division. Let's not do synthetic division on the questions that have an a value other than 1. Okay? Don't do synthetic division if your a value on your divisor is other than 1. So if you have a 2, a 3, anything that's not, if it's x minus 3, go for it, use synthetic division. But if you have a 2x minus 3, don't use synthetic division, okay? The idea, the rule is this: if the a value of your divisor is not 1, then you must use long division. You cannot use synthetic division. It gets complicated. So number 20 right here, looking at this rule, are you going to use long division or synthetic division? There's a 3 right here, not a 1. So I would not use synthetic. I would actually use long division. So I apologize. In the morning classes, I said, yeah, you could use synthetic division on anything. It's not necessarily true. If your a value is not 1, don't use synthetic division. If it is 1, like if this were just x plus 1, go for it. Use synthetic division, and you'll have a minus 1 inside the box. You have the coefficient 6, minus 1, and 7. And yeah, go for synthetic division. But it's not 1, it's 3. So don't use synthetic division. Use long division. So even on the first couple of questions, you can't use synthetic division or even long division. Why would you do that? The best thing to do is to split the denominator into each term. Like for example, right here it's saying this polynomial divided by this monomial. Okay, so let's write it with the negative 6x squared y on the bottom. And so what we're going to do is split the negative 6x squared y. I'm sorry, I said that wrong. We're going to split the negative 6x squared y to each and every term. So we have negative 30 x to the third y over negative 6x squared y, and then plus the 12x squared y squared over negative 6x squared y, and then minus 18x squared y over the negative 6x squared y. Then after that, you just cancel things out. For example, negative 6 and negative 30, that's positive 5. X squared on the bottom with 2 of the x's up on top only leaves you 1 x up on top. This y and this y cancel out. The negative 6 and the 12, you get a 2 left over, but that negative sign, you should write it probably up here next to the 2. The x squared on top cancels with the x squared on the bottom. The bottom y cancels out with one of the y's, so you have one y left up on top. And at the very end, we have, you could call this a negative 18. That'll cancel out with a negative 6, and you'll have a positive 3 left over up on top. The x squares cancel and the y's cancel. So what's our final answer? We have 5, which is negative, because there's a negative sign right here. We also have an x with that negative 5. And then if we look at the next term, we have negative 2 and a y. So that's going to be plus negative 2y. Or you could just put minus 2y. And at the very end, we have a positive 3. So notice we didn't use long division on this one either. Okay? The only ones, we didn't use long division or synthetic on this one. So the only time you're supposed to use synthetic is when you have a nice binomial on the bottom, something like x minus 2, x plus 3, x minus 5, x plus 7, as long as you have a nice binomial on the bottom. So if we look at this most recent worksheet, this is the reason why I separated the worksheets into part A and part B, because all of these guys are set up with nice binomials on the bottom. So right here you're going to be able to use synthetic division. This one's synthetic division. All of these synthetic division. Once again, if you have, like for example, right here, synthetic works great. But if you happen to have like a 2 out in front of your x, don't use synthetic. You have to use long division. So right here, you could use synthetic. Go for it. It's a piece of cake. Let's do one more. Let's go for a challenging one. I'll go with 16. So what we're going to do is do synthetic. So how do you do synthetic? You set this equal to 0 and solve. So that means that inside your box you're going to have a negative 1. And now we need to list the coefficients which is 3 on the highest exponent, all the way down to the smallest exponent, and then your constant at the very end. But remember, you want to represent every single exponent term. So here's m to the 5th, so that coefficient on the m to the 5th is a 3. But then we have m to the 4th, and it's not there. There is no m to the 4th, so you need to represent that with a 0. Then you have m to the 3rd, you also don't have it. M squared, you also don't have it. M to the 1, you do have a coefficient on m. There's a 1 right there. Right in front of the m, there's a 1. And the constant at the end is a -1. And now you're able to use synthetic division. Bring down the 3, because as you go down, you combine. But as you multiply when you go up, you multiply when you go up. So -1 times 3 is -3. And once again, when you go down, you combine. So 0 minus 3, that's -3. Okay, and then when you multiply, -1 times -3, that's +3 up here. And then when you go down, you combine. 0 plus 3, that is 3. And then over here, you multiply. -1 times 3, that gives you back to a -3. And you combine again. 0 minus 3, that's -3 again. And then over here, you multiply it one more time. -1 times -3, that's +3. I know it's sounding ridiculous. And then when you go down, you combine 1 plus 3, that's 4. Okay, and last but not least, -1 times 4 is -4. Wait, why did I put that 4 in red? Sorry. And we need a line right here because it's going to be our remainder, and the remainder happens to be -5. So what's the correct answer here? Well, you're going to go with the 3, that's the first one, and it's going to be with m to the 4th. How do I get m to the 4th? Well, think about it. M to the 5th divided by m, it's going to leave you with m to the 4th. So m to the 4th is right here, m to the 3rd, m to the 2nd, m to the 1. This is your constant, and this is your remainder. So let's just fill out the rest. -3 m to the 3rd plus 3m squared minus 3m, and then plus 4. And then at the very end, we're going to write our remainder, which is going to be minus 5 over the original divisor, m plus 1. Ladies and gentlemen, this whole thing is our answer, and it's a lot faster than long division, but we were only able to use synthetic because we were dividing by a linear binomial. The a value was 1, there was no number in front of the m, and it didn't have a power. Okay? I hope this helps.